Alright, this is Circles Lesson 1. The first 7 questions refer to the picture at the right. First, we just need to name the circle. So remember, we named that circle based on the center point. I have a center point of P, so I would name it using the circle symbol and then a P. Name a radius. You only have to name one. There's more than one in this picture. P to A is a radius, P to C, and P to B. So pick your favorite one. I'm going to go PB, makes me think of peanut butter, and put a line segment symbol on the top. Name a chord. There are 2 different chords in this picture shown. There's either the chord from A to B, which is also the diameter, or there's a chord from D to E. Either one will work because they're both chords. Make sure you have a line segment symbol on top. The diameter, there's only one shown, and that's from A to B. Again, line segment on the top. Next it says name a radius that is not part of the diameter. Well, the diameter is here, so both P to A and P to B are part of that diameter, but P to C, it doesn't have the other half, so P to C would be the radius that's not part of the diameter. Next it says suppose the diameter is 16, what would the radius be? Well, remember, a radius is half of the diameter, so it would just be 8 centimeters long. And finally, if the circumference is 11 inches, find A to B. Remember, circumference equals diameter times pi. So if the circumference is 11 inches, this C is 11, that must equal diameter times pi. So how would I get it to just be AB, which, by the way, is diameter? How do I get diameter by itself? If it says diameter times pi, I have to do the opposite of times by pi, which is divide by pi. I'll need to use my calculator here and do 11 divided by pi. I guess you could write a fraction. Or if you type that into your calculator, and when I type this into my calculator, by the way, I am not using 3.14 as pi. That would be a estimation. I'm actually typing the pi button. You all have a pi button on your calculator. Even an iPhone smartphone has a pi button. If I do 11 divided by that pi symbol, I get rounded to the nearest tenth, 3.5. All right. That's the same kind of questions that were asked on 10 through 13. We know that the radius of a circle is 8, so that means the diameter is twice that, which would be 16 centimeters. Finally, I know that the circumference equals either 2 or pi, like 2 radius times pi. Well, 2 radius is the same as a diameter, so I could say it either equals 2 radius times pi, or I could just simply say diameter times pi. In this case, I need to find circumference. I know the diameter, so stick a pi with it, and you've got your circumference. For number 11, I again have the radius. To find the diameter, I take the radius and times it by 2, so the diameter would be 26 feet long. And then the circumference is just the same diameter times pi. I still put a feet on there because we're measuring a length. Next, on number 12, I'm given the diameter and I need the radius. Well, the radius is half a diameter, so that means it'd be half of 9, which would be 4.5 meters long. To find the circumference, remember we take the diameter and times it by pi, so that'd be 9 pi meters long. Last but not least, number 13 is very similar to number 7 that we just did. We have the circumference and we want to know the diameter. Well, I know that the circumference equals the diameter times pi. I know the circumference is 35.7, and that equals diameter times pi. I want just diameter though, so I need to get rid of times by pi, and I can do that by dividing by pi. Again, I'm going to use my calculator. I'm going to put 35.7, and I'm going to divide and actually touch and push the pi symbol here. Remember, don't assume 3.14 is the same as that. That's not accurate mathematics. So if I do actually use the pi symbol and round to the nearest tenth, I get that the diameter is 11.4 inches long, which means then to find the radius, I'd have to divide that number in half, which would be 5.7 inches long. All right, let's look at the next set. we have circle R, and we know that AC and EB are diameters. We need to find each measure. Well, to get started, I think I'm going to go after what X is. I know that EB is a diameter, so therefore I know that these three must add up to 180. So that's how I'm going to start. I'm going to say I know 4x plus 15x plus 3 plus 7x minus 5 equals 180. If I add up all my x's, I have 4 plus 15 plus 7. 4 plus 15 plus 7 gives me 26 for my x's. And then if I add up my constants, I have 3 minus 5, so that's negative 2. That all equals 180. Next, I think I'm going to add the 2 over to the other side. So I have 26x equals 182. Next, just divide by 26 to get that x by itself. And I see that x equals 182 divided by 26, 7. All right, if x equals 7, then this piece would be 4 times 7, so 28 degrees. This piece would be 15 times 7, and then I have to subtract or add 3 to that, so 108 degrees. And this piece would be 7 times 7, which is 49, minus 5, so 44 degrees. You can check to see if you did that right by adding up 28 plus 108 plus 44, and it better give you 180 degrees. Okay, we're in good shape. Taking a closer look at this, how can I figure out these two pieces of the circle? Well, I remember I have a diameter from C to A as well, so this is a diameter as well. If you notice, we now have an X. I remember that the angles across an X from each other are congruent because they're vertical angles. That means this one in the corner of the X, the 44 degrees, must be congruent to this one in the other corner of the X, so this must also be 44 degrees. Similarly, that means these two added together, this big angle, which makes up the other corner of the X, must be congruent to this big angle down here. So that means 28 plus 108, 136 degrees would be down here. All right, now I think we could totally answer all of the questions they throw at us. It asks us for the measure of angle ERD, so I'm going to go from E to R to D, that's 28 degrees. It asks us for the measure of angle CRD, from C to R to D, that's 108 degrees. It asks us for the measure of BRC, angle B to R to C, 44 degrees. And A to R to B, ARB, 136 degrees. ARE, 40 degrees, or I'm sorry, 44 degrees. And BRD. BRD. Be careful. BRD takes these two angles and adds them together. So 108 plus 44, and that's 152 degrees. 152. All right, for the next page, let's add the information we know from the directions. I see in this picture the measure of angle PAU from P to A to U is 40 degrees, so right here is 40 degrees. And I see that the measure of angle PAU is congruent to the angle SAT. In other words, this one is also 40 degrees. And it's also congruent to angle RAS. So this one is also 40 degrees. And finally, it's also congruent to TAU. Oh my gosh, all of these are 40 degrees. Okay, cool. I see that this one is 90 degrees based on that little square there. Could we find this one? Yeah, pretty easily. All of those angles have to add up to 360. So I'm going to take 360 and subtract all of those 40s and that 90. 360 minus 40 minus 40, minus 40, minus 40. There's 4 40s, and minus a 90. And that gives me that leftover angle must be 110 degrees. Okay, now let's see if we can answer these questions. It asks us what's the measure of arc PQ. So from P to Q, that has to be the same as the central angle, so 90 degrees. It asks us the measure of arc PQR from P to Q to R, so that's 90 plus 110, that's 200 degrees. Which means that even though it looks like it, P to R is not a diameter. In other words, P to A, the center line, like here's P, here's A, there must be a slight bend when we go to R. You maybe can't see that bend. In other words, when I mean a bend, I mean that this is not a straight line. This must not be a straight line, or these would both have to be 90 degrees to make a 180 semicircle. So there must be a slight bend. You might not be able to see that bend. I know the picture looks like that's a straight line, that's a straight diameter, but if all 4 of these are all congruent, 1, 2, 3, 4, they're all 40 degrees, then over here is 160 degrees, which would not make a semicircle. So that means this is not a diameter. So be careful, looks can be deceiving here. All right, let's look at the measure of arc S to T, that's 40 degrees. The measure of arc R to S, that's also 40 degrees. The measure of major arc RSU, R to S to U, that's taking 1, 2, 3 of those 40 degrees, so 120. And finally, the measure of angle STP, STP. Again, 3 of those 40 degrees, so 120. All right, for the last one here, we're looking at this picture. We know the diameter of the shape is 18 feet long. Find the length for each arc. We're finding length here, so we have to use our formula central angle divided by 360 times by 2 pi times by 2r pi over 1. Okay, so if I look at the first one, number 28, I see that the measure of angle LDM from L to D to M is 100 degrees. In other words, the central angle is 100 degrees. Find the length of LM. So we would do our central angle, which is 100 degrees, over our 360 times by 2 times the radius. The diameter is 8 feet long, so the radius must be 18 feet long. So this really does equal 2r. So I'm just going to go ahead and do my central angle over 360 times by 18, which would equal my 2r. 18 pi, that's my circumference. Again, remember the formula is central angle over 360 times the circumference. Well, the circumference is just the diameter times pi. So my circumference in this, on all of these problems is going to be 18 pi because we're working with the same circle, so they all have the same circumference. I like to try to reduce this fraction first. I see that they're both divisible by 10, so I'm going to start by dividing both by 10. And then I get 10 over 36 times 18 pi over 1. Still, I think I can reduce because 10 and 36 are both divisible by 2. So I'm going to divide both these on the left by 2. I'm still just simplifying this fraction. 36 divided by 2 would give me 18. So now I have an unreducible fraction because 5 is prime. And I'm going to times that by 18 pi over 1. You can certainly cross-reduce these two 18s if you like. That means since I can reduce going sideways, just like I did reducing here, I'm going to divide the bottom left and the top right by the same number. And then finally I get 5 over 1 times pi over 1, which means when I multiply I have 5 pi over 1, so 5 pi, and we're measuring in feet would be the length there. Let's go ahead and do 29. This was 28. Here's 29. We have the measure of angle MDM. MDN is 80 degrees. Find that arc. So I'm going to do central angle over 360 times by the circumference, which would be the diameter times pi. And I'm going to go ahead and reduce 80 and 360. One number can go into 80 and 360. I think it's both divisible by 40. So the top would give me 2, the bottom would give me 9. And then I can times by 18 pi over 1. Looking here, I see I can also reduce going crossways. So if I divide both those diagonals by 9, I have 2 over 1 times 2 pi over 1, which gives me 4 pi for my answer. 4 pi feet. Remember, we're measuring length here. Let's do number 30. I see the measure of angle KDL, and I want to find KL. So the measure of that angle is 60 over 360 total times the circumference of the circle. If I reduce 60 over 360, I can divide both of those numbers by 60, which gives me 1/6 times 18 pi over 1. Both that 6 and that 18 are divisible by 6. So I'm going to divide diagonally by 6, or cross reduce. That means I have 1 over 1 times 3 pi. 18 divided by 6 is 3. 3 pi over 1, which gives me an answer of 3 pi. So I have 3 pi feet for this arc. We have one more, and that's number 31. I have the measure of angle NDK from N to D to K, and I want to find NJK. So perfect. I have the central angle, it's 120 degrees over 360 times by the circumference of the circle, which is that diameter times pi. I look to reduce. Well, I know that 12 can go into both of these numbers, so I believe that 120 will work. Yep, if I divide both the top and the bottom by 120, I get a 1 on the top and a 3 on the bottom, times 18 pi over 1. Looking diagonally, I can divide both of these numbers by 3, which means I have a 1 over 1 times 6 pi over 1, which gives me an answer of 6 pi. So I have 6 pi feet. Perfect.